Imagine, if you will, standing on the surface of Mars. Picture the scene unfolding before you, a landscape unlike any you've ever witnessed on Earth. The ground beneath your boots is not the familiar soil of home, but a fine reddish dust, coating everything in a layer of ochre. It's a landscape sculpted by eons of wind and radiation, and the sky above is not the vibrant blue we know, but a pale pinkish tan, a consequence of the thin atmosphere and the scattering of sunlight by the ubiquitous dust particles. It's a constant reminder of how different this world is. It's eerily quiet, almost unsettlingly so. The wind, when it blows, is a thin whisper, barely audible in your helmet, a stark contrast to the roaring gales that can sweep across the Martian plains. The sun, our life-giving star, is smaller and dimmer here, further away and filtered by the dusty atmosphere, casting long, strange shadows that stretch and distort across the rocky terrain. This desolate beauty, this alien vista, hides a deadly reality, a constant threat lurking beneath the surface of the red planet. You're only alive because of your suit, a technological marvel that separates you from certain death. It's a fragile barrier against a world actively trying to kill you. Your suit is your lifeline, a complex system of life support, communication, and protection. It's more than just clothing, it's a personal spacecraft, a bubble of Earth, a miniature version of the home you left behind, in a world that would kill you in less than a minute if that bubble were to burst. The atmosphere is so thin that it offers virtually no protection from radiation. Without it, the lack of pressure would make your body fluids boil, a gruesome and rapid demise. Your lungs would collapse, unable to function in the near vacuum of the Martian atmosphere, and you'd lose consciousness almost instantly, succumbing to the harsh realities of this alien environment. Mars is not a welcoming place. Every step is a calculated risk, a careful negotiation with a hostile environment. A tiny tear in your suit, a seemingly insignificant puncture, or a malfunction in your life support systems could be catastrophic, leading to rapid decompression and a fight for survival. You are over 100 million miles from home, separated by the vast gulf of space, a fragile speck in an immense wilderness, utterly dependent on technology and the support of a team millions of miles away. The planet is indifferent to your existence, uncaring of your struggles or your triumphs. It's simply, this sense of isolation and dependence on technology is at the heart of the Martian experience, a constant awareness of your vulnerability. We're drawn to Mars for its mystery and potential, for the possibility of discovery and the challenge of pushing the boundaries of human exploration. But survival comes first, always. Before we can build cities or raise families, before we can even begin to contemplate terraforming, we must learn to simply stay alive, to master the art of survival in this unforgiving environment. The journey to Mars is about more than rockets and advanced technology. It's about more than just getting there. It's about taming a hostile world, one problem at a time, with ingenuity, determination, and a relentless pursuit of solutions. The first and most immediate problem, the very air or lack thereof. The thin, unbreathable atmosphere is a constant and immediate threat. Mars challenges us at every turn, demanding ingenuity and resilience, forcing us to innovate and adapt in ways we never thought possible. To survive, we must adapt to a world that was never meant for us, pushing the limits of human capability and technological innovation. The very first and most fundamental thing a human needs to survive, no matter the environment, is breathable air. It's something we often take for granted here on Earth, a constant companion that sustains us with every breath. Earth's atmosphere is a carefully balanced mixture, rich in nitrogen and, of course, oxygen, the very element that fuels our bodies. Mars, however, presents a stark contrast. Its atmosphere is almost entirely composed of carbon dioxide, a gas that in high concentrations is toxic to humans. The Martian air is not only unbreathable, but it's also incredibly thin. It's like standing in a near vacuum, a pressure so low it would be deadly in seconds without a specialized suit to protect you from the elements and provide a source of breathable air. Breathing Mars's air, even for a short time, would quickly lead to carbon dioxide poisoning, with debilitating effects setting in within minutes. The oxygen content is a mere 0.13%, a negligible amount, nowhere near enough to sustain human life or any life as we know it. Mars's thin atmosphere also means it offers very little protection from the constant bombardment of meteoroids and space debris, and it carries almost no sound, creating an eerily silent and desolate world. The idea of simply shipping oxygen from Earth to Mars isn't practical, considering the sheer volume needed, especially when envisioning a self-sustaining colony. The only viable solution must come from utilizing the resources already present on Mars itself. To that end, scientists and engineers are diligently developing innovative machines specifically designed to split the abundant Martian carbon dioxide molecules and, through this process, produce usable oxygen. The Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, has already successfully demonstrated that this is indeed possible, marking a significant milestone. It efficiently pulls in the carbon dioxide from the Martian atmosphere and, using a sophisticated electrochemical process, separates the oxygen atoms, ultimately creating pure, breathable oxygen for potential future use. This groundbreaking technology represents our first real hope and a tangible pathway for transforming Mars's hostile air into something we can breathe and call our own. Creating a sustainable and reliable oxygen supply on Mars is absolutely fundamental and serves as the very foundation upon which any future Martian colony will be built. Without it, without breathable air, nothing else, no further progress or development can possibly follow. Therefore, solving the Martian air problem is undeniably step one, the essential first step in making Mars a truly habitable world for humanity. If the air doesn't kill you, the cold will. Mars is a frozen desert with average temperatures around -80 degrees Fahrenheit. Nighttime can plunge to -100 degrees Fahrenheit or lower, colder than anywhere on Earth. Habitats must withstand wild temperature swings and constant thermal stress. Spacesuits need advanced heating systems and reliable batteries to keep astronauts alive outside. Extracting water from frozen ground requires heavy, cold-resistant machinery. Keeping everything warm enough to function will consume much of a colony's energy. Reliable power and insulation are critical for survival on the red planet. Mars presents a unique challenge when it comes to gravity. It's not quite the weightlessness of deep space, but it's significantly less than what we're accustomed to here on Earth. Mars's gravity is only 38% of Earth's. Imagine feeling lighter, almost buoyant with every step you take. At first it sounds fun, jumping higher, lifting more, performing feats that seem impossible back home. The reduced gravity could make everyday tasks feel effortless, and athletic achievements could reach new heights. But over time, this low-gravity environment poses serious risks. Without the constant pull of Earth's gravity, our bodies begin to weaken. Low gravity weakens muscles and bones, leading to a gradual decline in physical strength and density. Astronauts who spend extended periods in space experience this firsthand. They lose bone mass and muscle strength at an accelerated rate compared to what we see on Earth. This puts them at a significantly increased risk of fractures and other long-term health issues related to bone and muscle deterioration. The effects can be debilitating and long-lasting. Returning to Earth after years on Mars without proper countermeasures could leave colonists too fragile to walk, requiring extensive rehabilitation to regain their strength and mobility. Imagine the challenges of adapting back to Earth's gravity after years of Martian life. To counteract this, colonists must exercise rigorously every day, a crucial part of their daily routine to maintain bone density and muscle mass. This includes treadmills for cardiovascular health and lower body strength, and resistance machines to work against artificial loads and stimulate muscle growth. Scientists are also exploring more advanced solutions, like maybe even artificial gravity, using rotating habitats to simulate Earth-like conditions. Low gravity also affects the heart and vision, impacting cardiovascular function and potentially causing vision problems. This is because without gravity pulling fluids down, they shift upwards in the body, leading to a puffy face and other physiological changes. Scientists are still learning about the full extent of these effects and are working tirelessly to develop effective strategies to prevent them and mitigate their impact on long-duration space travelers. Before we can settle Mars and establish a permanent human presence, we must ensure our bodies can adapt to the Martian environment and remain healthy over the long term. The challenge isn't just surviving the journey to Mars, but staying healthy and functional for the long haul, maintaining a good quality of life in a low-gravity environment. Mars will force us to rethink how we live, how we move, and even how we grow old, pushing the boundaries of human adaptation and resilience. Gravity shapes life as we know it. On Mars, where gravity is different, we'll have to actively shape ourselves to thrive. Understanding and overcoming the physiological effects of reduced gravity is absolutely vital for the success of any future Martian colony, ensuring the health and well-being of its inhabitants. Mars is constantly bombarded by dangerous radiation. Without a magnetic field or thick atmosphere, the surface is exposed to solar storms and galactic cosmic rays. A major solar event could deliver a lethal dose in hours. Chronic exposure increases cancer and nervous system risks. Protection is essential. Habitats must be shielded, ideally underground or covered in Martian soil. Water can also help block radiation. Colonists will need storm shelters and constant monitoring. Balancing protection, cost, and practicality is key. Radiation is an invisible threat, but one we must solve to survive. Every Martian home will be a fortress against the cosmos. Only with proper shielding can we hope to thrive on Mars. A self-sufficient colony needs its own food and water. Mars has water ice underground, but extracting it requires robotic miners and lots of energy. Every drop will be recycled, wastewater purified and reused, just like on the ISS. Martian soil is toxic and infertile, so farming must happen in climate-controlled greenhouses. Plants will grow hydroponically under LED lights, shielded from cold and radiation. Fast-growing crops like lettuce and potatoes will be the first staples. Greenhouses will be complex, closed ecosystems, recycling nutrients and water. Seeing living plants will boost morale as much as nutrition. Creating a sustainable food cycle is the ultimate goal. Without reliable food and water, no colony can last. Mastering these basics is the key to Martian survival. The first Martian shelters will be prefabricated inflatable habitats from Earth. But long-term, we must build with Martian materials. Regolith turned into concrete or fused with lasers. Habitats may be placed near water ice or inside lava tubes for natural protection. Underground bases or regolith-covered structures will shield colonists from radiation and temperature swings. Designs must balance safety with comfort, spacious, flexible, and psychologically healthy. Common areas, private quarters, and even virtual windows will help maintain mental health. As the colony grows, architecture must adapt and expand. The first outpost will be a marvel of engineering, a bubble of life in a hostile world. Building a true Martian home means blending technology, resourcefulness, and human needs. Mars's greatest challenge may be psychological. Colonists will be isolated, living with the same few people for years. Communication with Earth is delayed by up to 24 minutes, no real-time conversations. Astronauts must be self-reliant, able to solve problems without immediate help. Crew selection will focus on resilience and teamwork and stress management. Conflicts are inevitable, support systems and mental health tools are essential. The habitat is their entire world. No stepping outside for fresh air. Every system failure is a life or death emergency. The mental burden of isolation and dependence on technology will be immense. Overcoming loneliness is as vital as overcoming any physical danger. Despite the challenges, the dream of Mars is closer than ever. Reusable rockets and new spacecraft are making Mars missions possible. Life support and resource technologies are advancing rapidly. 3D printing and nuclear power could make self-sufficient bases a reality. The path forward: robotic missions, then short-term human stays, then permanent settlement. Each step builds on the last, turning science fiction into fact. The road is long, but for the first time we can see it ahead. Human ingenuity is rising to meet every obstacle. We're on the cusp of becoming a multi-planetary species. Mars awaits, ready for those bold enough to call it home.